All right, so you've probably built a neural network, right? And maybe you just stuck with the default settings. Well, today we're going beyond that. We are opening up the control panel to really understand how to tune the hyperparameters that define how a network truly behaves. Here's our game plan for today. First, we're going to look at the new architectural controls we get when we build a full network. Then we'll get into the activation switch, what makes the neurons fire. After that, we'll see how the settings we already know fit into this bigger picture. And to wrap it all up, we'll tackle the biggest challenge of all, tuning everything at once.
Okay, first up, layers and neurons. We kind of get how a single neuron works. But what happens when you scale that up? When you go from one single unit to this massive, complex machine? What new controls do you even get?
Let's think about it like this. A single Lego brick, well, it's not very interesting on its own, is it? But once you have a whole box of them, suddenly you can decide the width, the height, the whole complexity of what you're building. That's the exact same jump we make when we go from one neuron to an entire network. And these new controls have a name, hyperparameters. The best way to think of them is as the knobs and dials on the network's control panel. Now, what's really key here is that the network doesn't learn these from the data. Nope. We, the people building it, have to set these before the training even starts. So this gives us our first two huge new dials to play with. First, the number of layers. You can think of this as deciding how tall our Lego structure is going to be. And second, the neurons per layer. This one decides how wide each of those floors is. Together, these two settings define the whole shape and capacity of our network.
Okay, so we've built the structure, we've got our Lego tower, but now we have to figure out what happens inside of it. And that brings us to the activation switch, choosing how our neurons are actually going to fire.
This is such a critical choice. It's like choosing the light bulbs for every single socket in this new building we just made. Do we want a simple on-off switch or something a little more subtle? This switch is what determines how a neuron turns its input into an output signal. So that switch we're talking about, that's the activation function. And in the real world, the choice usually comes down to two absolute workhorses. You've got sigmoid, which is great because it squishes the output into a neat little range between 0 and 1. Perfect if you're trying to predict a probability. And then you've got ReLU. It's way simpler. If the input is positive, that's the output. If not, the output is 0. That simplicity makes it super fast and helps avoid some common training issues, which is exactly why it's the default choice for most layers these days.
This quote really drives the point home. You'd think that with all the research out there would be dozens of complicated functions to choose from. But in reality, people who do this for a living have found that for the vast majority of problems, these two are pretty much all you need. It's a perfect example of keeping it simple.
All right, so we've set the number of layers, we've got the number of neurons, we've picked our activation functions. But what about those controls we already know about from simpler models, like the learning rate? How do they fit into this much bigger, more complex machine? Well, it turns out they're more important than ever. The learning rate, which is basically the size of the steps the model takes while it's learning, is a really delicate balancing act. If you set it too low, training will take forever. But if you set it too high, the model just overshoots the best answer, kind of bouncing all over the place without ever landing. Finding that sweet spot is absolutely crucial. And it's the exact same story with the number of epochs. This is another one of those familiar dials. An epoch is just one complete run-through where the network sees every single piece of data in the training set. So picking the number of epochs is like deciding how many times the student gets to study the textbook before the final exam. Now that brings us to our final, and let's be honest, most complex topic, the tuning challenge. Now that we have all these dials, layers, neurons, learning rate, and everything else, how on earth do you juggle them all at once? Because here's the real problem. These settings don't work in isolation. You can't just tweak one dial, then the next, then the next. They all have to work together, in harmony. So how do you do that? And that's the key word right there, interdependence. These settings are all connected. If you change the number of layers, your old learning rate might be totally wrong now. If you add more neurons, you might need way more training epochs to get a good result. It's this complex, interconnected web. This interdependence means we can't just guess the best settings. We have to run experiments. Every column you see in a table like this is a unique recipe of settings we're trying out. Trying to find the best one creates this massive search space of potential models, and you have to build and train every single one of them just to see how it does. And that complexity is exactly why people call this whole process a black box optimization problem.
It's a perfect description. We know what we're putting in, our hyperparameter settings, and we know what we get out, the model's performance. But the stuff that happens in the middle, it's a black box. There's no clear map that tells you which combination is going to lead to success.
So that leaves us with a pretty big question, doesn't it? When you're navigating this complex, interconnected space, and you're often relying on trial and error and just plain intuition, does building these powerful models feel more like a rigorous scientific process, or is it actually more of a creative art form?
Hey, if this explainer helps you get a better handle on the control panel of neural networks, do me a favor and hit that like and subscribe button for more explainers just like this one. Thanks for tuning in.